Don't say the derivative.
No, f
Original
of x.
function.
I know what I would get if I plugged these in a derivative. I would get what number? And I get that on tests. Students go, well, at this value it's 0. I'm like, the derivative's 0, but we're looking for the absolute max and min of the function. So put them in here, right here. Get them in. Get them in. Now, I want to tell you what I did. Who likes to do tedious things in math? I know. This is what that tool is for. This tool is now going to become just supportive. Of course, we all know how to plug numbers in equations, right? We've been doing it our whole life. But has anybody ever used value? Let's go here now. I want you to go to y equals. Josephine, try this. Go to y equals. And if you had that derivative in there, I want you to wipe it out. I want you to put this guy in. So now I want everyone to go to their calculator and y equals, put this in there. You might find this easy. It just saves a little time. We all know how to plug numbers in. Of course we do. But this is a nice other feature of the TIs. J83 and 84. I put it in here. If your Windows out of whack, just hit Zoom 6. If your Windows out of whack, just hit Zoom 6. Now when I want to get these values. Did everyone get in y equals? Did you hit Zoom 6 to get like a negative 10 to 10 window? Alright. Go and you get a picture of the graph?
Yeah.
Josephine, you got a picture of the graph going? Alright. Go to second trace, which is the calc menu. What's the first thing on this list? By the way, there's a reason it's the first thing on the list. It's very popular. What's the first thing on the calc list?
Value.
Value. And what I want you to do, hit value, and right away, let's just start typing these numbers. What's the first number?
2.
Hit 2 and hit enter. What do you get?
Negative
Negative.
3.
Don't go off the screen. What's this next number?
Negative 1.
Hit -1 everyone and hit enter. What do you get? 8. Keep going. What's the next number?
Negative
Hit
two.
-2. Hit enter. What do you get?
Negative 3.
One more time. What's the next number? 3. Hit 3 and hit what?
Negative 44. Oh, see. Sorry.
What do you get for this one?
8.
Anyone say that? It's just a time what? Time saver. Do you follow me? I know you know how to plug numbers in. But when it comes to you could save sometimes 10 minutes where you'd be sitting on the front screen going, you know what I mean? The value button. It's very helpful in this scenario when you got to do this comparison. Everyone think about it. What if I got 6 critical points? I'm like, oh gosh, I can compare all these. Does that make sense? Now, who won this game? Who's the absolute max? Is there a tie?
Negative 1 and 3.
Yep. Now, how's the language? This is how we say it. All right? It's like, how do we fill this stuff in for these problems?
It's negative 8 for 3.
Yeah, it's negative.
Oh, you're the best. For 3, it's -8? My eyes are going, I apologize. Thanks for telling me that. And when you saw me read my calculator, and what did I say that was? 8. What's that?
Those points, 2 and negative 1.
Oh, right there.
Oh, okay.
And what are they called? There's a name for these. They're called the critical points.
Oh, okay.
And how do you find critical points? It's points are what? First derivative of x equals 0. So x values with first derivative of x equals 0, or we're at what?
Then
D and E. But we didn't have to worry about that. We didn't have any fraction or anything, true?
Will we ever have to like get one where you're not gonna give us an interval? So
That's
we can
next
just,
class.
So we can just find
He knows what's coming up. This, what we're talking about right now, everyone, will last, not only from 4.1, this will go all the way up to 4.3. We will be doing this all the time, but you just hit on it. You go, what if you don't have endpoints? Then we're looking at the locals or relatives, and we'll go find all the relative extrema. Find the relative or local extrema. Cool? Hey, now, the language. This is what we got to end on today, everyone. The language, the communication. Students mess this up. We're going to make sure on day 1 we never mess this up. Like, how do I speak? And students do this. Listen to this. Oh, okay. So the absolute max is -1. And you go, what do you mean? That's the highest number, right? So the answer to this question, the absolute max is -1. And the language is wrong. I'm not speaking correctly. What should I say? What is the absolute max?
8 at
It's
x.
the y value.
Yep.
So this is how you communicate. So this is what I would say. Ready? Ready? On the interval. What was the interval again?
Negative 2 and 3.
On the interval, -2 to 3, Alright? At x equal to, I'm gonna fill in a blank, the absolute max is, and I'll fill in a blank. You know what I might do? I may already write that for you. And then you fill in the what? Blanks. But if you ever wanted to write this on your own, you could speak like this. Okay, so on the interval negative 2, 3, the absolute max
At x
of f, I should say, of function f of x is, what goes here? The y value, which is the what?
8,
What's this value?
-1.
Cool. Now let's do another one for the min. That one on the interval, same interval, negative 2 to 3. See, I like to write that again on my test, just to remind a student, in case they forgot there's endpoints. You're only on that interval, right, Balraj? It's gonna be things tight off here, all right? At x equal 2, you gotta fill this in, the absolute min for minimum, of f is, let me put a blank. What's this? Which one was the
Two,
lowest?
2 and negative 19.
Negative 19, this was a. So I'll tell you where this gets forgotten though. So I'll present that like that, right? The final exam. You heard me saying I like to do a lot of multiple choice problems, right? But I also like to do some free response questions. And I'll have a problem, I give you a function, and I'll say, find the absolute extrema, okay? And you'll go through this problems. You'll go through this process. But it's there, I think. Maybe they're in the final exam mode, right? They're in the final exam mode, and guess how they write the answer? They go, the absolute max is -1. Right? Or they just circle -1. And they forgot the language. What's the language? We gotta say the max is what? The y value, it occurs at. Do you follow me? So it occurs at x equal to -1, but it is what? 8. Do you know why it's so important we speak like that? Why it's the y value?
Because there could be like.
It could be like temperature. So watch this. This is, I promise we'll go right for this. We got a temperature function going. Look at this. And here's June, right? Day 1, 0 to what? 30? June have 30 days? Alright, and the temperature went like this, right? Let's just say, and it went like this. Went up here, went like this. On June 16th, it got to like 98 or something, alright? And it came down like this. Alright, so you're saying this. Listen to this language. So the absolute max, this is F. You know it's temperature, true? I go, oh yeah, the absolute max is at 28. Or the absolute max is 28. 28 degrees Fahrenheit? What am I messing up? It occurred on the 28th day. It occurred on the 28th day. What was that absolute maximum temperature? It was what? 98 degrees Fahrenheit. Do you see how they messed? The language is you're reporting the y value as the absolute what? Maximum. This can model something in real life, like temperature. We don't, oh, the absolute max is that? No. The absolute max is 28. No, the absolute max is 98 degrees. When did it occur? On which day? The 28th day. Cool? All right. Hey, we didn't finish all 4-1, but we got into it. Have a great day. Balraj, we didn't finish 4-1.
No.
Some other little things in there. They got some graphs. They got some graphs. So, Art, I want to point out we didn't do all 4-1.
Okay.
Because remember we did, remember when we drew derivative graphs? They do something where they draw a derivative graph, they want you to draw it out. They want you to get an idea, and we'll do that. Yes! What class? Oh, I don't know.